Okay, so we can't, you guys should know this by now, we can't really introduce a new way of doing something without relating it to the old way of doing something, right? When we talked about radian measurements, we talked about how we get the radian measurements of an angle, right? And then we talked about, well, how do we convert that between degrees and radians? So there's always that idea of being able to express it in both formats, right? So this is going to focus on being able to express coordinates that are given as Cartesian, x and y, as r and theta, and vice versa. So basically what we're going to be coming up with is, and I don't like this word, but formulas for converting x and y coordinates into r and theta coordinates. All right? So let's take a look at this point right here. Okay, this point right here would be x units to the right and y units up. Okay, so this distance here is x, and this distance here is y. Everybody's okay with that, those displacements? Now, if I wanted to express this point not as going over and up, but as going around and out, that's the polar coordinate system, right? Around and out, I would need to know the rotation of this angle. How far off the polar axis did we have to rotate to get to that point? And what's r? R is the distance that we move away from the pole. So r is this measurement, okay? So I hope maybe you already see where this is headed, right? This x coordinate right here can be this side of a right triangle, and this y value here can be this side of a right triangle. So let's do r first. How would we find r if we knew these two values? Right? The Pythagorean theorem, x squared plus y squared equals r squared. And then let's take the square root of that. Okay? So what we have here, if you want to label this for yourself, I'm not going to write this down, but this is a formula for finding r if you know x and y. Okay? And I don't like formulas because I feel like they inhibit our own problem solving, but here you go. All right? Any idea why they call it r? Radius? Makes sense, right? Okay? Now, what about this thing right here? Assuming we don't know r, right? Let's take it back. Assuming we only know x and y, how do we find this angle, right? This is the angle theta. That represents the reference angle, okay? And in this case it is the actual angle, but it's the reference angle between the polar arm here and the polar axis, like so. How would you find this angle if you knew these two values, right? That's the opposite side, that's the adjacent side. So which right triangle trigonometric ratio involves the opposite side and the adjacent side, tangent? So we would have a formula that says the tangent of theta is equal to y over x. But if I just want to be able to use a formula to find theta, I'd have to take the inverse tangent of this. Okay, now, so we'll write this down, the inverse tangent of y over x. So here's our second formula. So here's how we find r if we know x and y. Here's how we find theta if we know x and y. Okay? Now, as long as you understand what theta and r represent, you don't need these formulas. You can just problem solve using right triangle properties. That's what these are. They're shortcuts of right triangle properties. Okay? One crucial piece of information here. Okay? When you find theta, every single time you find theta, you're finding a reference angle. You have to understand that. So it's still crucially important that we have the context of the coordinate plane here. Okay? And you'll see what I'm talking about when we look at a few of these examples. But if this point is over here, that angle that comes out of this is going to be a negative measurement. Okay? Why is it going to be a negative measurement? Super extra special bonus question. When we do the inverse tangent of a point that's over here, why is it going to be negative? Because tangent values are negative in quadrant 2, right? We've seen that by this point. Okay? So you have to have some context. This is always going to be the reference angle. Always, always, always. So you have to have the context of what quadrant you're in to accurately find the measure of theta. okay? And you'll see what I'm talking about once we do a few of these examples.